Okay, continuing on with 5.2, the zero exponent and negative exponents. So anything to the zero power is 1. So if we use our division rule and subtract the exponents, x to the first divided by x to the first would be x to the 0, and that should equal 1. So if we just cancel these x's, they would both become 1s, then our answer would be 1, or the same as if we used our subtraction rule for dividing exponents. So anything to the 0 power is 1. So a to the 0 power is 1, 4 to the 0 power is 1, 3 to the 0 power is 1. But if we have a number in front of something to the 0 power, that's a whole different program. A to the 0 power is 1, but the 2 is not raised to any power, so it's not affected by this 0. So this turns out to be 2 times a to the 0, which is 1, is 2. So when we have negative exponents, we want to change those to positive. So we do that by changing the position of the variable. So if it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. So generically, any variable to a negative power becomes positive if you move its position. So in this case, the negative m, x to the negative m has to change position, as well as the y to the negative n has to change position. So in an example with numbers, if we have 2 to the negative third power, this now is a number to a power, but it's negative, so it has to change position. 3 to the negative 4 has to change position. And then when we carry it out, we have 4 3's multiplied together, which would be 81 for our numerator. 3 2's multiplied together would be 8 for our denominator. We're moving into the next section here. We have negative 6s to the negative 2 divided by t to the negative 9. Notice that this is the sign of the number, nothing to do with a exponent. So the negative 6 stays in the same position. But the t to the negative 9 has to be moved up to make that positive, and the s to the negative 2 has to go down to make that positive. A little different when you have a fractional quantity to a negative power. So you make this 3 positive by changing the numerator and denominator's position. So the 2 becomes numerator and the a becomes the denominator. So now, when you carry it through to its conclusion, you're going to have 2 to the third power, which is 2 times 2 times 2. This part will become 8, and this is a variable, so we don't know what it is, so it's just a to the third. So products and quotients. Products, of course, means multiplication. Quotient means division. So our first one example is x to the fifth times x to the negative third. So we can do it one of two ways. This is multiplication, so we can add these. 5 plus a negative 3 equals 2. So it's x squared. Or we can say, okay, we better change this position of the negative 3, so x to the fifth stays where it is because that's positive. X to the negative 3 has to move its position, and then we can subtract 5 minus 3 equals 2. So you can do it one of two ways. In our next example, x is our common base. 3 divided by 7 means we subtract. So x to the 3 minus 7 is x to the negative 4. And we have to change its position to make it positive. Okay, when we get to the next one, we have x to the third power raised to a negative 2 power. This is our power rule where we have an exponent on the outside, an exponent inside the parentheses. So negative 2 times 3 is x to the negative 6. We don't want a negative exponent, so we change its position. This next one, remember we talked about cleaning up inside the parentheses, and that keeps with our order of operations. So the 2 is fine in this position, the a to the third is positive, it's fine, but this b to the negative 5 has to have its position changed. It has to become the denominator in the denominator. So now when we carry this out, don't forget to do the number part. So this is 2 times 2 times 2 for our 8. And then 3 times 3 is a to the 9th. 3 times 5 is b to the 15th.